Hi everyone, you're welcome back to our YouTube channel. This is the Skyline Institute. You're welcome to today's lecture of the SkyMath Series. For more videos and educational content, please follow us on Instagram at Skyline Institute GH and on Facebook and YouTube at Skyline Institute Ghana. Remember to also subscribe to our channel and give this video a thumbs up. You can also send in your comments, questions and feedback in the comment section below, and you can let us know other topics you'd be interested in learning.
So today we'll be looking at expansion and factorization. Do well to stay tuned. We'll start by looking at the multiplication of binomials. So a binomial is an expression involving two terms. Example, x plus 3, y minus 5, 2x plus 3y are all examples of binomials. To multiply two binomials, you simply multiply the individual terms of the first binomial by the terms of the second binomial, as shown below. Given the binomial a plus b and c plus d, their product is given by the first term of the first binomial a multiplied by the whole binomial c plus d plus the second term b multiplied by the whole binomial c plus d. Examples of binomial multiplication. Given x plus 3 times 2x minus 5, you first take x, which is the first element of our first binomial, and multiply it by 2x minus 5. And then you take 3 and multiply by 2x minus 5. This gives you 2x squared minus 5x plus 6x minus 15.
Now our final answer will be 2x squared plus x minus 15.
Another example, given 2x plus 3 squared, this simply means 2x plus 3 times 2x plus 3. So multiplying this binomial expression gives you 2x times 2x plus 3 plus 3 times 2x plus 3. Expanding this gives you 4x squared plus 6x plus 6x plus 9, which gives you 4x squared plus 12x plus 9. Next, we want to look at how to factorize algebraic expressions. So factorization is the reverse of expansion or multiplication. Factorization is achieved by the method of identifying common factors and the method of grouping to obtain common factors. By identifying common factors. Given 3ax plus 6ay, you look at both terms to identify factors that are common to both. Now, 3 is a common factor of 3ax and 6ay because 3 can divide 3ax and also can divide 6ay. A is also a common factor to both terms. A can divide 3ax and A can divide 6ay. X and y are not common factors. This is because x can divide 3ax but cannot divide 6ay. Y can divide 6ay but cannot divide 3ax. The common factors are therefore 3a. So what we do is we factor out our common factors to obtain 3a times x plus 2y. You can see that once we multiply back 3a by our binomial, we obtain the original question. So our final answer is 3a times x plus 2y. Let's look at another example. Given the expression 2x squared y exponent 4 minus 6xy cubed, you first look through to identify the common factors. we can see that 2 is a common factor to the term 2x squared y exponent 4 and 6xy cubed. X is also a common factor to both terms. Y cubed is also a common factor to both terms because y cubed can divide 2x squared y exponent 4, leaving an answer of 2x squared y, and can divide 6xy cubed. Y exponent 4, on the other hand, is not a common factor to both terms because even though it can divide 2x squared y exponent 4, it cannot divide 6xy cubed. Our common factors are therefore 2xy cubed. And this gives us an answer of 2xy cubed times xy minus 3. Now I want to look at factorization by grouping. We'll take an example. Given the expression x squared minus ax plus bx minus ab, the method of grouping simply groups the first two terms as one and the second two terms as a pair. We then look at each pair to identify the common factors like we did in the previous slide. Taking the first bracket, x is common to x squared and ax, and so we can factor x out. And then b is also common in the second bracket, and so we can factor b out. Now you can see that x minus a is now a common factor to the terms x times x minus a and b times x minus a, and so we factor x minus a out this time around, leaving a final answer of x minus a times x plus b. Another example, given mx minus ma plus nx minus na, we group our terms in two brackets. The first two terms are mx minus ma and the last two nx minus na. Next, we look at our terms to identify the common factors. M is common to mx and ma, and so we factor m out, and then n is also common to nx minus na, and so we factor n out. This gives us m x minus a plus n times x minus a. And this reduces further to x minus a times m plus n because x minus a is common to both terms. Here are some practice questions to try your hands on. Factorize the following. You can type your answers in the comment section.
So we've come to the end of today's lecture. Please remember to subscribe to our YouTube channel and click on the notifications button below. Remember to send in your comments, questions, and feedback in the comment section below. Thank you so much for watching. Bye.